Did you know the core switch enabling electric vehicle rapid charging and mobile phone fast charging is actually this chip smaller than an ant? It looks like a triode, but hides revolutionary switching technology. How do these three mysterious pins control the life and death of the entire circuit? Gate G, a smart main switch with built-in capacitance. Source S, the inlet for current. Drain D, the outlet for current. When the gate receives a signal, it's like installing a water pump for the capacitor. Applying voltage to the gate makes the capacitor act like a water reservoir starting to fill. When the water level voltage reaches the activation threshold, the channel from source to drain is instantly open and current surges through like a flood, enabling devices to start in milliseconds. This is the instant-on magic of MOSFETs. Once the gate is grounded, the capacitor discharges in milliseconds, like draining the reservoir. The gate immediately locks, completely cutting off the current path. With a response speed 100x faster than traditional switches, the circuit stops instantly. Compared to the continuous current loss of triodes, MOSFETs use electric fields for switching, with zero contact wear, ultra-low power consumption, and the switching frequency up to 10 MHz. This is the secret to its role as the core of fast charging. Your phone's fast charging, electric vehicle battery management, and even satellite power systems all rely on the small chip. With 100 billion MOSFETs produced annually worldwide, they support a trillion-dollar electronics industry, the energy masters of the micro world. If you have any questions about MOSFET product technical solutions, you can leave a message in the comment area. I will give you the answer here. VBsemi MOSFET manufacturer, focusing on MOSFET R&D and manufacturing for 20 years.